So hello, in this video I am going to show you the code and what I did for basically making this bulls and cows game. So I first printed all the rules here for the bulls and cows game. I'll show you running this also later, but then first I'll explain the code. Okay, so I'll tell you the rules of this game. So basically a computer chooses a secret code, a 4-digit secret code. In that secret code, all digits should be different. No number, as in no, the 0 should not be the initial digit, because 0 is the initial digit, then um, it won't be a 4-digit number. Okay, and then then the computer generates the code, and then the person has to guess that secret code, and for the person also there are the same rules. Okay, so after every guess, the person will get number of cows, number of bulls, and entropy. So number of bulls is correct digits at the correct position. Number of cows is correct digits but not at the correct position. Okay, this is what I have written in the bulls and cows games rules. I'll explain you the codes. Okay, so first we created a function generate secret code. In this function, a computer is generating the secret code. Okay, it is given a list of digits and random using the imported random module here. Using the random module, it is generating any of the digits except from 0, and then we are removing that digit from the list because we don't want the digits to get repeated, right? And at the end we get the computer has the secret code with itself. Now the bulls and cows logic or the bulls and cows calculation. Okay, so in this S is the secret code and G is the guess. So we check if the if the secret code is equal to the guess for this in zip. Okay, I'll explain what this does. So if the secret code is 1 2 3 4 and guess is 4 5 6 7, so what zip does is it zips the first digit of secret code with the first digit of guess, and same for the second, third, and fourth digits. So it makes pairs like 1 4 in bracket, of course, and then 2 5 like this. This is what it does. Okay, and for the cows, we just match that the number in that digit should be in secret code and in the guess also, and then we remove the bulls because obviously. Okay, so now we are looking at the function to calculate all possible secret codes. So we are doing this to generate a set of all possible codes due to with taking help of which we calculate the entropy. Okay, so we are calculating all possible combinations that can be made. So the same thing we did, we chose the first number from 1 to 9, not 0, and then the second digit, that is B, from any of these numbers. But then if B equals to A, that is the second digit is the same as the first digit, we skip that thing. This is how it goes, and then it appends. Okay, and the secret code set of all possible secret codes is generated. Now we look at the function to validate a user guess. Okay, so we need to validate a user guess, like checking does it has 4 digits, as in the length of the secret code is 4 digits, the first digit is 0 or not, and then all of these are digits or not. Okay, or it has no repeating digits or not. Okay, so if any of this fail, the guess is ignored and the candidate set stays the same. And one thing that I want to mention is that any invalid guess does not affect the entropy. Okay, because that is not counted in the candidate set. So now we'll see how do we measure entropy of uncertainty. So basically entropy is a way to measure how many possibilities are still left. Okay, and the formula that we use for entropy is h of s is equals to log base 2s. Okay, as s is this, set that we generated. Um, for every valid guess, the it reduces the size of guess, which means entropy goes down. It will happen every time. Okay, and it will show the entropy after each guess is made. Now we'll look at def filter candidates. Okay, so after getting bulls and cows from each guess, this is the filter candidate set. This removes every possible secret code and keeps only those consistent with the feedback. So entropy is recalculated with this new S. Okay. Now, next is partition by feedback. Def partition by feedback. Okay. So, as Professor mentioned, to decide a smart guess, um, I did this basically. So, I need to know how each possible secret would respond to guess. So for a guess, I group all secrets in S by what feedback they would give. Okay, this gives me different possible outcomes and how large each group would be. Now we are learning about expected information gain. Those above are some comments which I'll remove later. Um, yes, expected information gain. So in this we are calculating entropy before the guess. Okay. Um, so for each possible feedback group, this thing, we'll calculate probability and entropy after each guess, which is this. And it is calculated by this formula, which I don't want to take anyways. So it will give you, oh sorry, this is expected information and gain. Expected information and gain. Yes. Okay. So basically what this tells is, this function, it tells us that if I choose a guess, how much uncertainty will I reduce on an average. Now we look for the best guess strategy. So this is my strategy that I prefer. Let's split the candidate set into balanced groups and then reduce the worst uncertainty cases and give the most informative feedback on an average. This will help player to get a good information and make corrective or thoughtful guesses after that. So this will help you to pick the guess that will teach you the most. This will basically help you to minimize the number of turns to find the secret. Okay, now coming to the main game code. So this is def play. One. Yeah, okay. So I told you the S set, all the secret codes it is generating, and secret is generate secret code. So now it will print. I'll show you how this works. This is showing the computer has already chosen a secret number. Guess the 4-digit secret number. Type quit to exit if you want to quit the game in between. Okay. Yes. Now here what we are doing is just we are importing all the functions that we used above. So this is we are taking guess from the user as an input function. So enter your guess, like I entered yes 1, 2, 3 and 4. Okay. So after this it will give you a feedback. We see that it is giving you bulls and cows basically after each turn. And then it is updating the candidate set which I showed you above. And now it is calculating entropy before and after each set, and it is giving this. Entropy after this guess this much, and realized information gain this much. Okay. Now check win. If b equals to 4, the correct secret code was this. Okay. That is all. So in this guess, there is 0 bulls and 2 cows. Either of this can be. I'll make my another guess to get the digits. 5, 6, 7, 9. Out of this also we have 2 cows. So basically 8 and 0 are not my digits, because we get 2 cows from here and 2 cows from here, so we eliminate 8 and 0. Now we can play the game which I already played once in the earlier video, so I think this is fine for now. Thank you.